Hello viewers, this is Wargadaro taking you through today's tutorial for O-level physics. And this tutorial we're going to talk about questions on milliammeter as an ammeter. Now these are the very questions I left in the previous video, and I believe by now you're ready to try them out and ready to mark yourself and check your progress. So we shall start with question 1. Question 1 came from UNEB 2019, paper 1, question 50, and part A says that how is an ammeter different from a voltmeter in terms of resistance? So here we shall say that an ammeter has a lower resistance than a voltmeter. So if you wrote that, that would be 1 mark. Now we shall go to part B Roman 1. Part B Roman 1 say that how can an ammeter be adopted as a voltmeter? Remember, a voltmeter has a higher resistance. So in this case we shall say that by connecting a resistor of high resistance in series with the ammeter. So if you wrote that, that will be your 1 mark. Now shall go to part B Roman 2. Roman 2 say that a milliammeter of full scale deflection of 5 milliamps and resistance 76 ohms is to be converted into an ammeter, milliammeter to ammeter, of full scale deflection of 0.1 ampere. Find the size of the resistor to be used. So in this case, when you're converting a milliammeter to an ammeter, we connect a shunt resistor in parallel with the ammeter, with a milliammeter. So this is the milliammeter and this is the resistor to be connected in parallel with it. So Ig is the current through the milliammeter, which is 5 milliamps, and Is is the current through the shunt resistor, and this I, capital I, is the total current, which is 0.1 ampere. So if we do that, we shall come and say that Ig is equal to 5 milliamps. To change it to ampere, it will give you 0.005 ampere. Then after that, I'll have to remember that the total current I is equal to Ig plus Is, and I know that Ig is 0.005 and I is equal to 0.1. Therefore, when I substitute, I'll come up with my Is, and when I make Is the subject, will be 0.095 amperes. So now that I've got the current through the shunt resistor, I can now go ahead and remember that PD, since they're in parallel, it will be that PD across the galvanometer or milliammeter is equal to PD across the shunt resistor. So I'll come and say that PD across the galvanometer is IGRG, and PD across the shunt is ISRS, which is that. Now when I substitute, I'll come up with that step, and I think you can see that I have RS as the unknown. Now when I make RS the subject, I'll come up with my RS as 4 ohms. So basically that's the size of the resistor which has to be used. Now let's see how marks can be awarded. So half a mark for getting the current through the shunt resistor, and half a mark for equating the PDs, for equation for PD across the galvanometer being equal to the PD across the shunt. Another half a mark for the substitution, and half a mark for the total resistor which was required. So basically that's how the 2 marks could come about. So now shall go to question 2. Question 2 came from UNEB 1999, paper 1, question 10, and say that a galvanometer has resistance of 5 ohms and a range of 0 to 40 milliamps. Find the resistance of the resistor which must be connected in parallel with the galvanometer if a maximum current of 10 ampere is to be measured. So here I shall say that Ig, which is the current, first of all the diagram is in that form, and now we shall say that Ig, which is the current through the galvanometer will be equal to 0.04 ampere. Is converted from milliammeter to from milliampere to amps. Then I'll have to come and remember that total current is equal to Ig plus Is, and when I substitute, I'll be able to come up with my Is being equal to 9.96 ampere. Now that I know the current, I'll come and remember that PD across the galvanometer is equal to the PD across the shunt. When I substitute, it will be that, and substitute for the values to be, I'll be able to have my RS as the only unknown. And when I substitute for when I make RS the subject, I'll come up with my RS being equal to 0.02 ohms, and basically that's what they wanted. Now let's see how much can be awarded. So have full mark for you to get the current through the shunt, and full mark for you to equate the PDs, and full mark for substitution, full mark for the final answer, which is the 0.02 ohms. So basically that's how the 4 marks could come about. Now we shall go to question 3. Question 3 came from UNEB 1997, paper 1, question 9, and part A says, why is an ammeter constructed such that it has a low internal resistance? Here we shall first say that the main function of an ammeter is to measure current. So if it is to measure current, it implies that a low internal resistance allows current to pass through it without any loss. Remember, resistance is the opposition to flow of current. So if the main function of an ammeter is to measure current, it means that the internal resistance has to be as low as possible so that current can pass through it without any loss or opposition. So if you wrote that, that's how you could get the 2 marks. Now we shall go to part B. Part B says that a milliammeter has an internal resistance of 4 ohms and a full scale deflection of 0.015 amps. Calculate the value of the resistor that must be applied to the milliammeter so that a maximum current of 5 amps can be measured. So still our diagram will be the same, it will be in that form. And now we shall come and say that total current is equal to Ig plus Is, and when I substitute and make Is the subject, I'll come up with my Is being equal to 4.985 ampere. And now that I've got the current, I'll come and say that PD across the galvanometer is equal to PD across the shunt, and write the formulas, then substitute to come up with that. When I make RS the subject, I'll come up with my RS being equal to 0.012 ohms, and basically that's what they wanted in this part. Now let's see how much can be awarded. So have a mark for substitution and have a mark for you to get the current through the shunt. Have a mark for you equating the PDs, have a mark for substitution, and a full mark for you to get the resistance which was required. So basically that's how the 3 marks could come about. Now we shall go to question 4. Question 4 came from UNEB 1988, paper 1, question 8, and it says that a galvanometer of full scale deflection 15 milliamps is converted into an ammeter of full scale deflection 3 amps. So from 15 milliamps to 3 amps by connecting a low resistance shunt in parallel with the galvanometer. So part A says that what will be the maximum current through the shunt. Remember the diagram is in this form, therefore we shall come and say that the total current is equal to Ig plus Is, and when I substitute I'll be able to come up with my Is being equal to 2.985 ampere. So basically that's what they wanted in this part, and marks will be awarded in that way for you to get those 2 marks. Now we shall go to part B. Part B says that find the resistance of the shunt if internal resistance of the galvanometer is 5 ohms. So the one that resists RS if RG is 5 ohms. So we shall come and say that PD across the galvanometer is equal to PD across the shunt, and therefore when I substitute the formulas are like that. Now substituting the values, I'll come up with that, and when I make RS the subject, I'll come up with my RS being equal to 0.0251 ohms, and basically that's what they wanted. Now let's see how marks can be awarded. So half a mark for equating the PDs, half a mark for substitution, and half full mark for getting the resistance which was required. So basically that's how you could get the 2 marks. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions, but this time the questions will be on electrostatics, and this topic is basically taught in senior 2 term 3. That means that if you're in senior 2, senior 3, senior 4, then these questions will be good for you. So that brings us the end of this lesson. Thank you for watching, and be reminded that the solutions for the assignment left in this video will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can always receive updates when the next video with the solutions has been uploaded. Otherwise, if you know of any student who is not yet in this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.